Hi and welcome to On Maths Topic Busters. Today we're looking at surds. Don't forget there's no reason to be absurd. Enjoy! Hi and welcome to this On Maths Topic Buster. So, today we're looking at surds. Now, surds just mean a square root of a number that you can't just find the square root of. So, root 4 is not a surd because that's 2. But root 2, on the other hand, is a surd because you can't write it in a different way other than using the surd. Surds are horrible numbers if you try and write them as a decimal, but they look quite nice. Root 2 looks very nice. Now, in the days before calculators, surds were quite a complicated thing to work with, and so a lot of the methods we're going to show you in this video are pre-calculator understanding of how to deal with surds. So rationalizing the denominator is a really good example of what people had to do before the calculator. I hope you enjoy the video. If you enjoy it, then fantastic. Let me know. Thank you. Okay, so in this first question we're doing root 11 times root 3. Now what we need to know is the fact that that is going to be the same as this. And that's one of the rules of surds. Anytime you times two surds together, you just times the numbers and put it all in a root. And 11 times 3 is just 33. Now the next one, it just has the surds next to each other, but that means the same as root 5 times root 3. We just put them next to each other. So that's going to be the same as root 5 times 3, which is just root 15. Last one, you might notice something special about both these numbers, but we're going to pretend we don't, and they're just two surds. Well, technically they're not surds, but we'll come to that later on. So, doing the same thing, 4 times 9. Now I know 4 times 9 is 36, but I can work out the square root of 36, and technically it's 6 and minus 6, but I'm just going to write it down 6. Alternatively, root 4 is 2, and root 9 is 3, and 2 times 3 is 6. Okay, have a go. Okay, so to do the first one, we know it's just the same as root 5 times 2, which is root 10. The next one is the same as root 3 times 13, which is just root 39. And the last one is the same as root 4 times 25, which is the same as root 100, which is 10. Or we could have just found root 4 times root 25. 2 times 5 is 10. Brilliant. Okay, so we're asked to simplify root 20. So the way I do that is just write the factor pairs of 20, so 1 and 20. Well, 1 and 20 we'll never need for this, so we can skip that one. So 2 and 10, 4 and 5, and I think that's it. And we look for square numbers. Well, the only square number here is 4. So we're going to use this factor pair here. So I'm going to rewrite that, and I'm going to put the square number first. So I'm going to do root 4, root 5, which we know from the previous video that's the same as root 20. But instead of root 4, we can write 2. So it becomes 2 root 5. Okay, let's do the same with the next one. So we're looking for 125. Now, with numbers that are like this size, you're probably just thinking, okay, well, is it in the 25 times table? Is it in the 100 times table? And instead of writing all the factor pairs, I just know that that's 5 times 25, and 25 obviously is a square number. So that's the factor pair I'm using. Now, I'm going to put the root 25 first, and then the root 5. So I put the square number first. Root 25 is 5, so it becomes 5 root 5. Now the reason we put the square number first is the number always goes before the surd. If we put the number after the surd, if we put 5 root 5 the other way around, it kind of looks like root 55 if we're not careful. So we always make sure the number goes at the front, not at the back. Now this last one, what I do is I just completely ignore the 3 before the root 32. So I'm just looking at 32 for now. Now again, I know that 2 times 16 is 32 and 16 is a square number. So the factor pair is 2 and 16. So what I'm going to do is I'm just going to change the question to just root 32. And that is the same as root 16. Square number goes first, root 2. I know root 16 is 4, so it's the same as 4 root 2. Now 3 root 32 is just 3 times bigger than that. And what you do is you just times the 4 here by the 3 here. So it becomes 12 root 2. So work out the surd on its own and then times the number on the outside of the surd by the number on the outside of the surd in the question. So we just times the 3 and the 4 together to make 12. Okay, have a go yourself. So the first one, I'm going to do the factor pairs of 8. Well, I know that 2 times 4 is 8 and 4 is the square number. So I'm going to write that as root 4 root 2. Don't forget to put the square number first. Root 4 is 2, so that's just 2 root 2. This time, 200, we're going to find factor pairs of 200. And again, I just know that 100 is going to be the biggest square number in that. So that's our factor pair there. So that's the same as root 100 times root 2, and root 100 is 10. So it's the same as 10 root 2. The last one, I'm going to ignore the 5 and just look at the 18. And that's 2 times 9, with the 9 being the largest square number. So root 18 is the same as root 9 root 2. Root 9 is 3, so that's the same as 3 root 2. Then we've got to do the 5 times it, so we've ignored the 5 till now. So I'm just going to times the 5 and 3 to make 15 root 2. Okay, now one of the other rules with surds is if you've got a square root, you can just root the top and root the bottom. So if you've got a square root in a fraction, just root the top, root the bottom, and that's absolutely fine. So root 5 stays at the top because that's a surd, but root 9 is 3. There we go. Next one becomes root 4 over root 20. Now root 4 is 2, but root 20, let's have a think. Root 20 is 4 times 5, and 4 is a square number. So we can simplify that further. So that becomes root 4 times root 5, which is 2 root 5. So over 2 root 5. And then I can divide top and bottom by 2, and it becomes 1 over root 5. So you can simplify that one quite a lot, and be careful. I knew that the 5 and the first question couldn't be simplified anymore, which is absolutely fine. But when you have larger numbers, check that you can't simplify them further by using the methods in the last video. Okay, this last question, what you can do is just put the numbers next to each other and then put the surds next to each other. So 4 times 9 is 36, times 10 times 5 is root 50. But again, 50 has a factor pair with a square number. It's 2 times 25, and 25 is a square number. So I can simplify that further. So it becomes root 25 root 2. Root 25 is 5, so it's 5 root 2. So that becomes 5 root 2. So 36 times 5 root 2. And so I need to do 36 times 5. and I can do that with long multiplication or a times by 10 and halve it, so I know that that's going to be 180 root 2. Okay, have a go. Okay, so for the first one, root 7 over root 16, so it becomes root 7 over 4. The second one, root 9 over root 24, and that becomes 3 over, well, let's have a look, 24 is 4 times 6, so it becomes root 4 root 6, so 2 root 6, so that's over 2 root 6, and we can't cancel any further there. And this last one, so let's put the 3 and the 8 together, and the 2 surds together, root 3, so that's 24 times root 36, aha, so that's 24 times 6, and I know 25 times 6 is 150, so take away 6 is 144. Okay, so these three questions kind of look a bit algebra-like, and the ways we deal with them are pretty much the same as you would with algebra, but this time we're using surds, not letters. So the first one, now I notice that root 75 can be split up. I know that root 75 is the same as root 25 times root 3, so that makes that the same as 5 root 3. And I can do the same with root 27. That's root 9 times root 3, and so that's 3 root 3. Now the first term isn't root 75, it's 2 root 75, so instead of 5 root 3 it's going to be 10 root 3. And the second one, instead of 3 root 3, it's got a 3 before it, so I'm going to times the 3's together to make 9 root 3. So the 3 here, I'm timesing by the 3 here to make 9. Now, like algebra, if this was 10x plus 9x, you would know it was 19x. Surds work the same way, but instead of x, we've got root 3. So 10 lots of root 3 plus 9 lots of root 3 are 19 lots of root 3, and that's our answer. Now, that we didn't need to expand, which is why I put brackets around the top. We just needed to simplify that. For the second one, we do need to expand it as well. Now, the way I do these ones, and there's absolutely no right or wrong way, there's loads of different ones. I use grid, okay, just like I would for algebra, expanding quadratics. And I put the first bracket at the top, so 3 plus root 2, and the second bracket down the side. And it doesn't matter which way around you do them. And we're going to be timesing these. So 3 times 2 is 6. 2 times root 2 is just 2 root 2. 3 times minus root 2 is minus 3 root 2. And minus root 2 times root 2, so that's going to be a negative. And whenever you times a surd by itself, it gets rid of the square root. So that's just 2. Then I'm going to put these together like I would with algebra. So 6 plus 2 root 2 minus 3 root 2 minus 2. So the 6 take away the 2 is the 4, and we've got 2 root 2's and we're taking away 3 root 2's, so that leaves minus root 2. So minus 1 root 2, but we don't bother putting the 1. Okay, this other one, first of all, most important step is whenever you square something, you're timesing it by itself. So we're squaring the bracket, so we're timesing the bracket by itself. Do that first of all. If you've got a bracket squared, just write out the bracket twice, and that will show you how to do it, because it's exactly the same question as we've just answered. So I'm going to do my squares, and we're going to put this bracket at the top, so 5 minus root 3, this bracket down the side, so 5 minus root 3. 5 times 5 is 25, 5 times minus root 3 is minus 5 root 3, minus 5 root 3 here as well, and minus and minus is plus, and root 3 times root 3 is just 3. So we've got 25 minus 5 root 3 minus 5 root 3 plus 3. So 25 plus the 3 is 28. And minus 5 root 3 take away 5 root 3 is minus 10 root 3. Okay, have a go. Okay, so for the first one, root 32 is just root 16 root 2, which is 4 root 2. Root 200 is root 100 root 2, so that's 10 root 2. So I'm going to do 3 times 4, which is 12 root 2. And then I'm going to do 10, well, there's nothing on the outside there, so it's just 10 root 2. 12 plus 10 is 22 root 2. Okay, next one, I'm going to do myself a little grid. Probably a bit small, you might want to do yours a bit larger. So 2 root 3 and 4 minus root 3. So 4 times 2 is 8, that would be 4 root 3 minus 2 root 3 and minus 3. So it's 8 plus 4 root 3 minus 2 root 3 minus 3. And we've got these that can collect together, so 8 take away 3 is 5, plus, and we've got 4 lots of root 3, we're taking away 2 of them, so we're left with 2 lots of root 3. Last one, rewrite it so that it's 2 brackets, and we go through the same process. So we do our grid, and at the top we've got 3 minus root 5, at the bottom we've got 3 minus root 5, 3 times 3 is 9, 3 times minus root 5 is 3, or minus 3 root 5, minus 3 root 5, and minus and minus is plus, root 5 times root 5 is just 5. So we've got 9, take away 3 root 5, take away 3 root 5, plus 5. The 9 and the 5 add together to make 14, and we've got minus 3 root 5, take away 3 root 5, so it's minus 6 root 5. Okay, so for these questions we're asked to rationalize the denominator, which is just a posh way of saying get rid of the surd from the bottom of the fraction. We don't care where the surd is, as long as it's not at the bottom of the fraction. So for the first question we've got 5 root 3, and all we need to do with this one is just times it by 1. But we're going to show 1 as root 3 over root 3, which is the same as 1. But by showing 1 as root 3 over root 3, have a look at what happens. At the top we get 5 root 3, but we don't care whether there's a surd there. But at the bottom, root 3 times root 3, any surd times itself just gets rid of the square root. So that's 3. So we've rationalised the denominator. Brilliant. Let's go on to the next one. So we've got 10 minus root 2 over root 2. All we need to remember with this one is whenever you've got an expression in a bracket, whether it's algebra or with surds, just put a bracket around it. Trust me, it will help you later on. So we're going to do the same with this. We're going to times it by 1, but by 1 we mean root 2 over root 2. Now this time we've times in the top by root 2, so I'm going to put root 2 at the outside of that bracket, and the bottom is just root 2 times root 2, which is just 2. Now I could expand that bracket, which is absolutely fine, but there's no need to. It hasn't asked me to expand any brackets, it just says rationalise the denominator, which I have done. Okay, let's have a look at the one at the bottom. We've got 4 over root 3 plus 2. Now, here, if I times by root 3 top and bottom, that actually won't get rid of the root 3. If you just quickly root 3 brackets root 3 plus 2, then yes, it will get rid of it there, but then it will create one when you do the when you do the rainbow. When you times root 3 by 2, you'll end up with a 2 root 3 at the bottom. So unfortunately, that's not going to work. Let's just get rid of that. So we've got to think, right, okay, let's put brackets around it. How would I get rid of that? There is one way and one way only to do it. If you times top and bottom by an identical bracket, but with a different sign, so that was root 3 plus 2, if we do it root 3 minus 2, let's have a look what happens. And I've got to do the same to the top, so that the fraction as a whole is 1. So at the top I get 4 root 3, root 3 minus 2. But at the bottom we get root 3 plus 2, root 3 minus 2. And let's just expand that. So I'm going to use this space over here. Oop. Just going to use this space here. Okay. So we've got root 3 plus 2. We've got root 3 minus 2. Okay, root 3 times root 3 is 3. 2 times root 3 is 2 root 3. Minus 2 times root 3 is minus 2 root 3. And minus 2 times 2 is minus 4. So when I put that together, we get 3 plus 2 root 3 minus 2 root 3 minus 4. 2 root 3, take away 2 root 3, gets rid of them. So we're only left, if I write out the top again, and you can expand the top if you want to, but if you don't need to, I wouldn't bother. 3 take away 4 is minus 1. So it's minus equals minus 4 root 3 take away 2. Okay, have a go. Okay, so I'm going to times top and bottom by root 2 for this question. So we end up with 4 root 2 over 2. Now some of you might notice that you can divide top and bottom by 2 here, so we're just left with 2 root 2. Okay, this next one we're going to times top and bottom by root 7, and we're going to put brackets around the question. So it becomes root 7 brackets 8 minus root 7 over 7. That's absolutely fine. Okay, and the last one, we know that we've got a times top and bottom by root 2 minus 3, so the opposite sign as in the question. So that would be 6 bracket root 2 minus 3, and the bottom, well, we just need a bit of work to find out what it would be. Let's just do a crude grid. Okay, so we've got root 2 plus 3 and root 2 minus 3. So root 2 times root 2 is 2. That would be 3 root 2 minus 3 root 2, and that would be minus 9. Okay, so we've got 2 plus 3 root 2 minus 3 root 2 minus 9. These two you just get rid of because they cancel each other out. So 2 take away 9 is minus 7. So our answer is minus 6 bracket root 2 minus 3 over 7, or we can just leave the negative at the bottom. Thank you very much for watching this Topic Busters. If you enjoyed this one and want to see more, please look at our YouTube account. Just type in onmaths on YouTube and we come up. Otherwise, go to the website onmaths.com and you can have a go at all of our predictions, Topic Busters, demon questions, mini mocks and countless other things. Thank you very much.